Hi, this is exercise 4E.1, building on what we've already seen regarding to the Wilcoxon test, the Wilcoxon signed rank test and the Wilcoxon rank sum test. Now, these two tests have certain problems in as much that the critical values only go up so far in the formula book, and in the textbook as well. So if you look at those critical values, I think for the signed rank test it goes up to 20, and for the Wilcoxon rank sum test, the m and the n have to be lower than 10 or else you can't do it. And this on here, let me just get the pen up. On here it says if it's more than 10, either n or m more than 10, then you've got problems. So this is when we do it. And the bizarre thing is really that we end up doing this by pretending it's a normal distribution. And I say that's bizarre because the whole point about the Wilcoxon test was that you didn't have to assume anything about the distribution. And here we are having to assume it's normal in order to be able to do it. But the normal is what we assume. Just be aware then that on the normal approximations for this is what we use for mu, and this long formula is what we use for the variance, sigma squared, which look horrendous until you realise they actually tell you them in the exam. Again, for this test, this is the mu, and this is the sigma squared. Just bear in mind I'm going to talk about continuity corrections. We have to care about what are called continuity corrections because we go from something either of these two tests which ends up giving us a number for the test statistic, whether it be t that we eventually get for this one, or we get w when we do this. And these RM or W plus or W minus, which is what that's meant to say, these are kind of the statistics we use along the way to then tell us what the T is or what the W is. Now, these are whole numbers, so you might end up with, for instance, a RM of 112. You would never get 112.74 because it's all to do with ranks. And yet we are then trying to approximate them using something called a normal distribution, which is continuous. You can get some horrible decimal number. And the way we take that into account is we apply a continuity correction. We effectively adjust the number that we get by 0.5, and I'll show you that in a bit. So here, let's look at this question. We've got a Wilcoxon signed rank test, and it says on 32 items. So straight away I'm thinking n is 32. And it says the sum of the positive ranks, so that's W plus, is 196. Now technically I should try and find W minus. And you just need to be aware that the sum of the ranks, now I've said it in this red box here, is equal to this half n plus 1. And in this case it's a half of, what was it, 32 times by n plus 1, 33. It's not overly clear, but you get the idea. So on my calculator I'll do that sum and I get 528. So all the numbers added together equal 528, and therefore to get the W minus I do 528 minus what I got told, 196. So minus 196 equals 332. Now the rule says for the Wilcoxon signed rank test you take the smaller of the two, so I'm going to use that number. And just bear in mind then that this W plus is meant to be normally distributed, and according to these things here, so my mu is this, so I'm going to type into my calculator, a quarter of 32 times 33, and I get 264. So you'd expect to get a score of 264 if you did this test. And according to the normal distribution anyway, I'll do 1 divided by 24 times by the n 32 times by n plus 1 33 times by 2n plus 1, which is 65. 2860, so I get 2860 for the variance. So that tells me I would expect to get a normal distribution down the middle is 264, but I actually got, what was it, 196, quite a way away, it's there. Now this is where the continuity correction comes out. I just go, I want to find this probability, but rather than using 196, I'm going to use 196.5, and I add 0.5 onto this figure, and I get a little bit inside it. And that takes account of the fact that the next number is 197, which I could have got, but there's a gap between the two. So I use 196.5 to take account of that. And I'm going to find the probability that x is less than 196.5. So I go into my calculator menu 7, 2. The lower number is negative 9999. The upper number is, what was it, 196.5. Sigma is the square root of 2860, and mu is 264. 0.103. Now this is greater. And well, I'm assuming it's greater. It's a two-tailed test, so therefore it's 10% each end. Yeah, I was right. So it's a 20% test, which is unusual. But this is greater than 10%. So I'm going to tell you now, this is do not reject. And I vaguely remember actually not saying that. I only just wrote out the answers to this. So I'm going to say do not reject H0. It has to be underneath. Yeah, I knew it did. So this is, and that's just, where's my pen gone? That is bigger than, so we do not reject. And therefore, with a wordy bit, it says it's insufficient evidence to say that the median is different from what we thought before. Here's another go. We'll just do a similar question. So we've got a Wilcoxon rank test. So the sign rank test. So n is 120. It tells me the sum of the positive ranks is 400. Okay, 400. And notice this time it doesn't make me calculate W minus. It says the sum of the negative ranks is 3260. So I'll take the smaller one. And I can say that W minus is approximately normal. And let's just do this a quarter of 120 times 121. 3630. So on these tests you'd expect to get 3630. And we're going to do the same thing. 1 divided by 24 times by 120 times by 121 times by 241. That's a big old number for the variance. 145,805. Okay, fair enough. So here's my normal distribution. I'd expect to get a mean of 3630. The W minus, I actually got 3260, which is a little bit smaller. Is it far enough smaller? That's the question. Remember my continuity correction again. I'm not going to use 3260. I'll go inside it. 3260.5. So I'm going to find the probability that W minus is less than 3260.5. Let's do that. Menu 7 again. So I'm typing that into my calculator. Using the continuity correction, remember, it was sigma. It's a square root of 145,805, and mu was 3630. And this time my probability is 0.167. Now this is, what is it? It's a two-tailed test at the 10% level. Two-tailed, 5% each end. So this is bigger than 5%. So this is another do not reject. It's not. See if I got the question right this time. Do not reject H0. Insufficient evidence to say that the median is different from prior belief is cut off at the bottom. You get the idea. So now we've got this second type of test. It's called a Wilcoxon rank sum test. We've done this before, but this is one where we can't do it. And if you just look at it up here, the M is, the small one is 12 and the big one is 20. They're both bigger than 10, and 10 is the magic number which I can't then do. So notice it wants me to do a one-tailed test. Median difference is 0, median difference is bigger than 0. At the 10% significance level, okay? The RM value is 240. Now, I've looked at this. You don't really need to bother with the other one, so I'm just going to write RM 240. Therefore, we would expect this to be a normal distribution. I'll calculate it using this formula, so it's menu 1. So what have I got? I've got 0.5 times M, which is 12, times by M plus N, that's 32, plus one more is 33. So I get 198. And if I do a 12th of, it says M times M. So 240 is that, times by the same thing again, those added together plus the extra 1, which is 33. I get 660. So again, I expect to get a normal distribution with 198 down the middle. What did I get? I actually got 240. I'm on the right hand side this time. So this is good. I want this probability this time, but I don't use 240. I go inside it. So I use 239.5. That's my continuity correction again. So here I write RM. Oh, sorry. The probability that RM is greater than 239.5 is. So I'm going to do 7. So this time my 239.5 is my lower. My upper is 9999. My sigma is the square root of 660 and 198 for my mu. This will give me 0.0531. Now what was it again? This was a 10% significance level, one tail test. So 0.0531. Now this is less than 10%. So this time I do reject H0. Sufficient evidence to say that the median difference was greater than 0. And of course in this question they gave me the hypotheses, I didn't have to worry about those. I've got one more similar one to that. I'm not sure if I've done this one yet. Let's just see. In terms of answers, we'll soon find out, I suppose. What's it got? It's got m equals 10. Well, that's fine. N equals 17. So I can't do a critical value. I therefore need to do this test. It says the null hypothesis is 0, and there's another one which is saying it should be less than 0. And it found the RM value to be 165. Well, let's find out what we would have expected it to be. RM is normal. Using this formula for the mean, I've got it at 10 and 17. So it's a half of 10 times by 10 plus 17 plus 1 is 28. Is that right? 27, 28. Yes, it is. Oh, we're in the wrong mode. So let's do it again. A half of 10 times 28. And I've got 140 for the, so I'd expect to get the RM value to be 140. And what's the variance? So 1 divided by 12 times by the two of them times together, which is 170, times by that 28 again, which is the 10 plus the 17 plus 1. And I get a not so nice 1190 over 3. But I'll write like that. So I get my normal distribution, the expected mean is 140. What did I get? The RM value I got to be 165. But I don't use 165. I go back again. And I use 164.5. It doesn't matter. If I'm on this side, I add a little bit on. If I'm on this side, I take it away. Come inside it. I want that probability. The probability that RM is greater than 164.5 equals, let's try this, menu 7 again. So 164.5. And the upper is 999. Sigma 1190 divided by 3. And I hope I typed that right. 164. No, what was the mean? 140. Nearly got that one. 140. And my probability this time is 0.109. Now it said to test it at the 10% level. There's only one, but this is greater than 10%. So do not reject. So I can't remember if I've done this answer. Certainly recently. That's the same answer anyway. Insufficient evidence to say that mean difference is less than 0. So look, a bunch of questions there, and that's, you know, if you get questions on this exercise which are not like that, just completely ignore them for now. I've certainly developed a second PowerPoint for this because there's other ones I want you to do. So if you see anything a bit weird on this exercise, miss them out for now. And there's a mixed practice for you as well there. So best of luck on those, and I hope they're okay.